You ever see the news and wonder how one part of the world is getting hit with record-breaking floods while another is suffering through a historic drought? I mean, it seems like a total contradiction, right? Well, what if I told you that a tiny, slow and steady change in our planet's temperature is the single domino that knocks over everything and causes both of those extremes? Okay, let's get into it. So this is the big puzzle we're going to solve together. It's a really fascinating look at how our planet systems are all connected. Seriously, how can one root cause, a warming planet, lead to two completely opposite disasters? Well, the answer is a chain reaction, where one little change kicks off a whole cascade of much, much bigger events. To really wrap our heads around this, we need to follow the trail of breadcrumbs right from the very beginning. Let's trace the path, starting with that very first domino to fall. The starting point isn't some big, dramatic explosion. Nope, it's actually a slow, kind of sneaky, but totally relentless increase in the average temperature of the air all around us. And that simple fact is the engine for everything that's about to happen. Okay, so now we have to talk about a key scientific process here, evaporation. You've seen this a million times. You know how a puddle on the pavement just kind of disappears on a hot day. That's evaporation. Heat turns liquid water into an invisible gas, water vapor, that rises up into the atmosphere. This is the absolute crucial link between temperature and water. So, here's the key. When the air gets warmer, it basically becomes a super-powered sponge. It sucks up moisture faster from oceans, lakes, you name it. And the result? The atmosphere gets loaded up with a whole lot of extra water vapor. All right, so now we've got all this extra moisture hanging out in the air. The big question is, where does it all go? This is where our story hits a fork in the road, where it splits into two totally different paths. And this is how we start to make sense of that whole flood and drought paradox. So think of the world's wind patterns like a massive global delivery service. Their job is to pick up all that water vapor and ship it around the planet. But, and this is a huge but, it's not an even-handed delivery service. Some places get way more than they ordered, while other places see their deliveries get diverted somewhere else entirely. And this lays out the two outcomes perfectly. On one side, you have winds just dumping all that concentrated moisture over certain regions. That means heavier rain, more intense storms, and rivers that can't handle all the water. In other words, you get floods. But on the flip side, because those same winds are carrying moisture away from other areas, those places get left high and dry. They see less rain, their snowpack shrinks, and eventually they face really severe droughts. So this right here, this puts it all together. This is the whole journey we just walked through. You start with rising temps. That leads to more evaporation and more water vapor. Then the winds spread that vapor around unevenly. And that creates one path that ends in floods and another that ends in droughts. It's incredible, really. One single cause with two completely opposite effects. Now, of course, this isn't just a model on a slide. This is actually playing out in real communities all over the world right now. So let's take this from theory to reality and look at two very different places. Let's meet our two communities living these opposite extremes: Vicksburg, Mississippi, and Porterville, California. Vicksburg is literally drowning in water, while Porterville is desperate for every last drop. And yet, believe it or not, their stories start in the exact same place. Over in Vicksburg, they are squarely on that more water vapor path, and the data here is crystal clear. As the average temperature has ticked up over the years, so has the total amount of rain they get. All that extra moisture we talked about is being delivered right to their doorstep, and it's completely overwhelming their river systems. And this headline, wow, it was written by a student who was living through this crisis, and it just perfectly captures the human side of all this data. This isn't just about charts and numbers, it's about people's lives and homes being completely turned upside down. Now, let's jump all the way across the country to Porterville. They're on that other path, the less water vapor one. Temperatures are rising there too, but the wind patterns are carrying all that moisture somewhere else. The result is just not enough water to refill their water sources, and you can see this dramatic, scary drop in the groundwater that they absolutely depend on to survive. And once again, this headline just cuts right to the heart of it. This isn't some abstract, far-off problem. We're talking about the very real, very personal struggle of just trying to find enough water to get through the day. So let's zoom back out for a second. Looking at these two stories and the science that connects them, what's the big picture here? What's the main thing we should take away from all this? It really boils down to three huge points. First, and this is so important,
Small, steady changes in one piece of Earth's system can have absolutely massive impacts on another. Second, the fact that we're seeing more intense floods and more intense droughts isn't a coincidence. It's directly tied to rising air temperatures. And finally, we've solved the paradox. The exact same engine, an atmosphere holding more water vapor, is what's fueling both of these opposite extremes. It all just depends on where the wind decides to drop off the delivery.
And that brings us to one last really big question to chew on. We've just seen how a seemingly small shift in temperature has already kicked off these enormous, contradictory problems. So if this is what a small change can do, it really makes you wonder, as these systems keep changing, what happens next?